Okay, so number 1 over tangent b plus tangent b equals secant squared over tangent b. Oh, I do want to share this with you here. As I was kind of thinking about what are the 3 kind of like the big ideas in terms of, I think the hardest part is always that first step, right? I think we agree. That first step is always the most difficult. Like, what do we do? And I want you guys to consider 3 things. The first is, consider that there is a identity to use, right? Whether it's a Pythagorean identities or maybe there's an identity that we can instantly use. Okay, so that's potentially an option. Second is a possibility is also converting to sine and cosine, right? Because we know everything can be represented in terms of sine and cosine. And the third is maybe it's a factoring problem. Maybe there's a GCF that can be pulled in front. Okay. And I would say maybe there's a 4th option here is sometimes we need to consider maybe a common denominator will get us started with the problem. And some of the more complicated ones that you guys saw on the quiz is where an identity is not available, but you can kind of create something out of nothing, right? You guys did that on the quiz, right? You're able to find a function to multiply into the expression to create an identity. All right, so identity, convert to sine and cosine, factoring. I would say those are probably takes care of, the majority of, your first steps is always one of those things. It's always going to be one of these things, right? So go down your checklist. Okay, so number 1, this one, I guess we could convert to be in terms of sine and cosine, but I'm looking at the right side going, well, I'm kind of already sitting in tangent, which I want to show up. So I'm thinking, well, maybe common denominator could help me get something started, especially if I'm trying to, start with two terms and trying to merge it into one. Okay. Common denominator being tangent of b. Okay. First fraction, no balancing needed. I can bring down that 1 without any issue. The second term, however, second fraction, old denominator is missing a tangent b, so I need to multiply by tangent b. So tangent squared b. Merge those together, and we should be nearing the end. Okay, 1 plus tangent squared becomes secant squared, right? And that leads us to our end expression. Okay, any questions with 1? Okay, number 2, 1 over cosine squared over sine 2x. looks like we have an opportunity to expand that, right? Double angle, and then potentially a identity to use as well. Okay, give that a try. Okay, so double angle, I know sine of 2 theta becomes 2 sine theta cosine theta. 1 minus cosine squared x becomes sine squared x. Okay. Do some cleanup here. One of the signs can go away. Okay, how can we make this look like the right side? Yeah, turn a tangent. And what is that 2 in the denominator? Same thing as 1/2, right? So really just the same thing as 1/2 times sine x over cosine x. Right? And you know sine over cosine is tangent, so. Okay, for number 3, it's a little tricky here, but a couple of hints. Use I know there's a couple of options to choose from, but use the cosine squared minus sine squared x. Okay, and the second hint is try to rewrite in terms of sine and cosine. Okay, is everybody okay with number 2? Do your common denominator step in the denominator portion, and then we're going to see something that's going to line up nicely with the numerator. Okay. What's the common denominator for the bottom portion? It's cosine squared, right? Balance each fraction. Dividing by a fraction is the same thing as multiplying by the reciprocal. We should be able to get some things to line up nicely here. Everybody okay so far? See the numerator, denominator portion matches nicely. We can remove them. The only thing left is cosine squared over 1, which is cosine squared.
Can you explain how you went from big fraction to the multiplication?
Sure. So I'm dividing this by this, right? So dividing by a denominator is the same thing as multiplying by the reciprocal. What's the reciprocal of this denominator, right? It's cosine squared over cosine squared minus sine squared.
Oh.
Yeah, I'm just flipping this denominator up, and as I flip it up, I gotta change the order. Good. Any other questions with 3? Okay, take a look at 4 and see if you can decide what would be a good first step to take. Okay, what's a good first step, you think? Yeah, I'm looking at the right side. The right side is sine and cosine, so that kind of helps kind of guide my efforts a bit here. Sine and cosine, yeah. Push those together. It's already sharing a common denominator, so that's saves a step for us. Okay. Well, at least we have everything in terms of sine and cosine. That's matching up nicely with the right side, but we're not quite there yet, right? What could we do? Because we really don't have any identity right now. We already converted to sine and cosine. It's not really a GCF. We already have common denominator. Yeah, let's create an opportunity for an identity to appear, right? We're We're going to kind of create something out of nothing here. Right? If I can get cosine squared to show up in the denominator, then all of a sudden I have some options. Pythagorean identity, right? Okay. Okay. What can we do with cosine squared now? Mm-hmm. And factor, right? Denominator, difference of squares. We can get that 1 plus sine y to match and pair up. Okay, so that should take us to our where we need to be. Good. Any questions up to 4? Okay. 5? So number 5, I think this problem, that cosine 2x, it's a little too vague. I think it's a little bit easier to, in this case, start on the right side, move to the left side. So that's what I would suggest. Let's start on the right side here. That cosine 2x is a little bit too hard to get in terms of tangent. I feel it's easier on the other side. So if we start on the right side, trying to move our way to cosine 2x, what could be oh, and by the way, there are more than one way to work a problem. But what do you guys think here? Yeah, identity. 1 plus tangent could be secant. What do you think? Sine over cosine. Okay, all right, let's go that route. So you spot a denominator that we can do with this piece, right? 1 plus tangent squared is secant squared x, okay? Okay, that works. What would you do next? Okay. So basically, let's get everything to sine and cosine, right? That's basically what you're saying, okay? Multiply by the reciprocal. Distribute that 1 over cosine. Oops, sorry. If I multiply by the reciprocal, it's going to become what? Become cosine squared, right? Not 1 over cosine squared. Okay, is everybody good with that? Dividing by denominator is same thing as multiplying by the reciprocal. Okay, distribute that cosine squared through. What do we get? What's the first term? Cosine squared x, right? Second term will give me what? Sine squared, right? Numerator denominator goes away. Okay, will that take me to the end? Is this an identity? Yes. That's one of the options, right? One of the options for cosine 2x is cosine squared minus sine squared x. Okay, try number 6. Mm-hmm.
How did you go from, like, how did you go from, like, there?
Oh, from here to here?
Yeah.
So I know that tangent is the same thing as what? Sine over cosine.
Yeah.
Okay. So now I have this over this. I mean, I guess I could have found a common denominator, but what I did was I just multiplied. Dividing by a fraction is the same thing as multiplying by the reciprocal. So if I flip this, this will become, instead of 1 over cosine squared, it's going to become cosine squared over 1. And now I'm just going to just distribute this through. Distribute that through, I get cosine squared. Distribute this through, the cosine squared cancels out.
Gotcha. Great. Thank you.
All right, number 6. Any ideas? Double angle identity, right? We can just, let's get that into something that's easier to work with. And while we're at it, let's just turn cotangent into what? Yeah. We can merge those two parts together. Cosines can be merged, sines can cancel out. Okay, are we any closer to the right side? All right, what can we do next? Yeah, we know how to go from cosine to sine, especially if they're squared. So go ahead and make that adjustment. Cosine squared is the same thing as 1 minus sine squared, right? And now what can we do to make it match the right side? Distribute, yeah. Okay, I think number 7 is also one where I think it's easier to start on the right side and move to the left. I think the left side is just too little information to work off of. So we know we can do a lot of cleanup on the right side, so let's just start on the right side and move to the left. So usually it's easier to start with the more complex side and try to get it down to the simpler side, because just, yeah, otherwise if you start from the simple to the more complicated, you have too many options to help you move forward. Okay, everybody good with 6? Okay. Okay, any ideas about cosecant of 2x or cotangent of 2x? Yeah, just a flipped version of sine and tangent, right? So let's get them into something that we recognize. We find those double angle identities that we want to use. Sine of 2x is just 2 sine x cosine x. Tangent of 2x is 2 tangent x over 1 minus tangent squared x. Is there a quick way that we can get this in this right place? Yeah, let's just flip it, right? Rather than putting in a complex fraction, we know that if I want 1 over tangent x, I just want a flip version of this. So I just want the 1 minus tangent squared above and 2 tangent x below. I don't have an identity, but maybe I can get everything in terms of sine and cosine. How's that? That way, at least I can maybe find common denominator, because I have sine and cosine here. It'd be easier to match if I have sine and cosine here as well. So 1 minus tangent squared, the same thing as 1 minus sine squared over cosine squared. Yeah, I don't think I provided enough room for this number 7 here. Okay. Okay, common denominator. I'm going to get find another sheet to work on. Common denominator being cosine squared x. balance my numerator. This is missing cosine squared x. Do a little merging here. Now I have a common denominator. Dividing by a fraction is the same thing as multiplying by the reciprocal, so I'll multiply by the reciprocal, so it's cosine over 2 sine x. One of the cosines can go away. So the nice thing is that the denominator is actually going to match up nicely. This is 2 sine x cosine x. And the top is cosine squared x. Now that we have common denominators, we can make that all sit under one fraction. And my goal is to get it to look like tangent of x. So if I can just get rid of all the cosines in the problem, maybe that'll get me to where I want to be. But I want tangent though. Let's see. Oh, sorry, there should be a cosine down here. My bad, cosine. If I can get this in terms of sine, maybe I can get the sines to go away and have cosine, get tangent to show up. So this is basically cosine 2x, but there's another version of cosine 2x, right? Which is 1 minus 2 sine squared. So yeah, this is probably more difficult than what you can expect on the test, but it's a good one to go through. Distribute this through here, we get 1 minus 1 plus 2 sine squared x. The ones go away. Okay, the 2's can pair up. One of the sines can go away, and we're left with sine over cosine. Which is tangent of x. Okay, that's a messy one there. Okay, take a look at number 8. Anything catch your attention about this problem? Yeah, a quick way to kind of make our problem a lot easier. Identify some identities and get some messiness out of the way. What else? See any other identities that we can? Mm-hmm. Secant squared, right? What else do you see? Or what are you guys thinking? Yeah, I think there's a lot of ways to get there. You can split the fraction, produce another identity to get that cotangent squared. You can get everything in terms of sine and cosine. You can use an identity from here. 1 plus cotangent squared is cosecant squared. So I think there's a lot of options here. Those are all going to work. Okay. But I'm just going to convert this. I see another identity. I'm going to convert it, but splitting it into 2 fractions, I think will also be fine. So now if everything in terms of sine and cosine, I can get hopefully cosine over sine to show up. Multiply by the reciprocal. Okay, number 9. What you guys do for your first step for number 9? Yeah. See a bunch of cosine and sine, so easiest to match and pair up if I can get everything to just be sine and cosine. Yeah. Okay, what's next?
To get common denominator.
Yeah.
Multiply cosine.
Good. Yeah, common denominator. I see two fractions, so I like to add them together since the right side is only showing one term. So good. Common denominator. Second fraction doesn't need any balancing. First fraction does need the cosine up top. So there's more clarity here, right? Merge them together and we have an identity and we should be able to get that secant to show up. Okay, last one, number 10. Any questions with 9? Okay, what are your thoughts about number 10? Common denominator, yeah. I see two fractions on the left. I only see one term on the right, so I have to merge them one way or the other, so common denominator. Okay, what's our common denominator? Yeah, we need both, right? They're completely separate things. We need both to be part of our common denominator. Cosine and the 1 plus sine. Balance these fractions, see which denominator is missing what. First one is missing the 1 plus sine. And the second fraction is missing a cosine. One plus sine times 1 plus sine, we can FOIL that out. Okay, are we okay so far? All right, any what can we do to clean up the top? What does that give us then? Good. Okay, we're pretty close, right? We'd like to get some things to cancel out, but not perfect match yet. What can we do to create that match? Yeah, GCF, right? Take out a 2, and we should be able to get this to show up. Cancel, cancel. 2 over cosine. Flip that, and we get secant. Okay, any questions? Okay, help session tomorrow, 4th period. I'll try to come up with another, put together another review worksheet.
Are we gonna get back our cookies?
Oh, that's right, that's right. I gave it to Sophie, I've got to give it to you guys. Thank you.
No, it's not. Oh, that's
Oh, yeah, let me show you this here. We can look at the nuts on this thing.
How do you?
I know that, but I'll just like.
Whatever that is.
This was a question just so it's out of or for me, you just. Oh, maybe.
Yeah, it's, I would have added,
Oh, okay, 'cause okay, it wasn't marked up, but it, okay.
Yeah, that's what I was like. No, I'm not supposed to see it. What?
okay.
Maybe. No, I texted you. No, it's not today.
I would get there like
And
by.
it's gonna be safe, so obviously I get it. Like there are no way. Unless it's that.
No, because they're going the other way. Yeah.
$5, that might be worth the zero on the pin.
My mother. But you're so right. So my mom, you know, I'm trying to make. I'm kind of sick.
Question. Can you go over this one real quick? Cause I was having so much difficulty with it, even though it wasn't that hard.
Every day, guys, thanks for your test. This can broken down into one line. Split up.
I have to do that with the starting gun, right? Except I got like had it 9 and then I got 49.
I was wondering what I got wrong here.
Yeah. Let's see. Hi, have a good day. Oh. How did you get, you walk through the steps here? Did you cancel this out, or I guess I couldn't follow your steps, that's why.
I kind of like forgot because this problem I think was especially messy because like I think I changed these here first into I think cosine and sine and that one to secant. I changed secant into like cosine or something here. Yeah, I can't quite remember my styling. Here you circle something.
Yeah, I just couldn't. I thought this was what led to this, and I didn't see the connection from here to here.
Here I canceled. Here I canceled cosecant, and then I canceled the
We
sine.
gotta be careful though. We can't cancel if there's a minus sign. Would you
No,
factor
I
cosecant
canceled the other
out?
cosecant. There's another cosecant right here.
Right, but it's attached to this minus sign.
No,
Do
this one.
you factor cosecant out? We can't cancel these
Oh.
cosecants out if there's a minus in between.
Oh, I
You
don't
gotta
know.
factor it out.
Oh, okay, because I canceled this cosecant and
Yeah.
the sine.
I mean, I saw some steps here, but I just couldn't follow. So if you can explain it to me, I can give you credit. But I just couldn't follow it. That's
But
why.
yeah, I mean, that's
Yeah,
like.
the way that I did it was, I made everything to be sine and cosine, got that sine squared to be 1 minus cosine squared, and then split it into fractions and then get that cosecant minus cosine.
Okay.
Okay.
Can you go to this bonus?
Yeah. Let me show you.
Mr. Yang, can I keep working?
I'm sorry?
Can I
Yeah,
keep
you keep working, yeah. Which one was yours? Was yours the cosine sign or tangent?
No,
sign?
the tangent.
Okay, I convert everything to be in terms of sine and cosine and then common denominator and then
So it's 1 over. You did the common denominator. Okay. How'd you get this down here?
tangent squared can be written as sine squared over cosine squared, so it's 1 minus sine squared over cosine squared. And you find a common denominator, so cosine squared over cosine squared.
Oh, because 1 minus sine squared is cosine squared. And this is 1.
Yep.
So 1 minus sine squared over cosine squared. Cosine squared multiplies to the top. So it's cosine squared over sine squared.
So this becomes cosine squared minus sine squared over cosine squared. And then I flipped it to the top, which is then.
Ah, got it. So it's 1 over cosine squared.
Yeah.
Doesn't that secant? 1 over secant.
Well, I want to keep everything sine and cosine, just so I get everything matched up. Because I know I got to find common denominator, so I want everything to be matching up.
Got it.
And then here, these denominators are a little bit different, so I want to make them the same, so I need to factor a -1 out. So this becomes a negative,
Okay.
and now all of a sudden cosine squared minus sine squared can match this denominator.
Got it.
Yeah.
Does negative sine squared minus cosine squared equal 1?
Sort of. Negative sine squared minus cosine squared. I need to factor a -1 out first. Once I factor a -1 out first,
But equals negative.
yes, it does equal -1.
Ah, I got negative. Got it.
Okay. Mm-hmm.
So, Mr. Yang, the last question in the packet is an optimization problem.
Mm-hmm.